I'm here. I made it. Um, yeah, honestly, I do think it probably would be perfect because it's just a lot of reading. Um, I was listening to the streams we had done last year, just to like refresh myself before we started back up again. And they are so good just to like sit and listen to. I don't have to like look. Um, yeah, so today we're going to be doing hopefully like a longer stream. I don't know exactly how long we'll go. It's going to be basically till I feel like I've talked enough, you know. I think we'll just get right into it. There might be a lot of breaks. I might be really enjoying what we're doing. I'll be like, I don't want to take a break. We'll see. Maybe if it's like really stressful stuff we're going to be covering, but all right. Keywords and naming identifiers. This is 1.7. Keywords. C++ reserves a set of 92 words as of C++ 23 for its own use. Okay, so there's 92 words C++ has for its own use. These words are called keywords or reserved words, and each of these keywords has a special meaning within the C++ language. Here is a list of the C++ keywords. Oof. Okay, I'm not going to read all of these because that's a lot. I see like double, int, return, float. It's like the usuals, right? Friend is cute. Hey, Airhammer, how are you doing? All right, the keywords marked C++ 20 were added in C++ 20. Oh, okay. Oh. Concept. If your compiler is not C++ 20 compliant or... Oh, I don't know if that picked up. I feel like it did. The stream may drop or be spotty. I have faith in our systems here that the stream should be okay, but there is like a thunderstorm going on, and I'm kind of like, it's perfect for, you know, coding stream, but also not the best for actually streaming. But we're just gotta believe. I lost where I was. Or it does have C++ 20 functionality, but it's turned off by default.
Oh, no, man.
These keywords may not be functional. C++ also defines special identifiers: override, final, import, and module. These have a specific meaning when used in certain contexts, but are not reserved otherwise. We have already run across some of these keywords, including int and return, along with a set of operators. These keywords and special identifiers define the entire language of C++, preprocessor commands excluded. Because keywords and special identifiers have special meaning, your IDEs will likely change the text color of these words to make them stand out from other identifiers. Okay. Purple. Oh wait, but then they're... Okay, still special colors. Couldn't tell. I felt like I saw the mic, the little LED light here. I felt like I saw it pick it up. Oh, I have to talk to Shure support while I'm currently talking to them. They need like my entire computer specs. Like they need like to see my device manager, and it's like a whole thing. I've been putting off replying because I'm like, that was a lot you asked me for. Like, what the heck? But I can't get into their software to change the color of this, so it works out of the box at least. That's lucky. But I don't know if I could sound even better with what they have, but whatever. By the time you're done with this tutorial series, you will understand what almost all of these words do. Identifier naming rules. As a reminder, the name of a variable or function, type, or other kind of item is called an identifier. C++ gives you a lot of flexibility to name identifiers as you wish. However, there are a few rules that must be followed when naming identifiers. The identifier cannot be a keyword. Keywords are reserved. The identifier can only be composed of letters, lower and uppercase, numbers, and the underscore character. That means the name cannot contain symbols, except the underscore, nor white space, spaces, or tabs. The identifier must begin with a letter, lower or uppercase, or an underscore. It cannot start with a number. Whoa, that's interesting. I was surprised that the underscore was allowed, and then it was interesting that numbers aren't allowed. Okay. C++ is case sensitive, and thus distinguish between lower and uppercase letters. N value is different than N capital V value, is different than all capitals N value. Very interesting. Identifier naming best practices. Now that you know how you can name a variable, let's talk about how you should name a variable or function. It is conventional in C++ that variable names should begin with a lowercase letter. If the variable name is a single word or acronym, the whole thing should be written in lowercase letters. Okay. All lowercase is conventional. Unconventional is all of it. Oh, all over the freaking place, yeah. Should start with lowercase letter. Should start with lowercase letter and be in all lowercase. See your psychiatrist. That was literally like, hello? That's so funny. Okay. Most often, function names are also started with a lowercase letter, though there's some disagreement on this point. We'll follow this convention since function main. We'll follow this convention since function main, which all programs must have, starts with a lowercase letter, as do all the functions in the C++ standard library. Identifier names that start with a capital letter are typically used for user-defined types, such as structs, classes, enumerations, and all of which we will cover later. Okay. User-defined types, that feels like, yeah, my function name. So like stuff I would create for myself. If the variable or function name is multi-word, there are two common conventions. Words separated by underscores, sometimes called snake case, or intercapped, sometimes called camel case. That's what I know it as, camel case. Since the capital letters stick up like humps on a camel. This song is like, it's doing something in the headphones. I'm like, whoa. All lowercase, conventional, separated by underscores, snake case. Okay, start at lowercase, but then the next words are uppercase. That's kind of what I know to do usually. I feel like it's easier for me than trying to find the underscore. Just write the word, just hit the space bar, you know, or shift key. Oh my god. Unconventional, starting with the uppercase. That's wrong. No spaces. White space not even allowed. Okay, invalid. So this is literally will be rejected. Like that makes no sense to them. Okay. This is allowed, but like bad. In this tutorial, we will typically use the intercapped approach because it's easier to read. It's easy to mistake an underscore for a space in dense blocks of code. Right? Is that what they're saying? Like, we'll be doing the camel case one that I like. Intercapped, yeah. Good. We'll typically use the intercapped approach because it's easier to read. It's easy to mistake an underscore for a space in dense blocks of code, but it's common to see either. The C++ standard library uses the underscore method for both variables and functions. Sometimes you'll see a mix of the two. Underscores are used for variables and intercaps used for functions. Okay. That's a good rule of thumb. It's worth noting that if you're working in someone else's code, it's generally considered better to match the style of code you're working in than to rigidly follow the naming conventions laid out above. Yes. Best practice. When working in an existing program, use the conventions of that program, even if they don't conform to the modern best practices. Use modern best practices when you're writing new programs. Okay. Avoid naming your identifiers starting with an underscore. Although syntactically legal, these names are typically reserved for OS, library, and other compiler use. The name of your identifiers should make clear what the value they are holding means, particularly if the units aren't obvious. Identifiers should be named in a way that would help someone who has no idea what your code does to be able to figure out as quickly as possible. In 3 months, when you look at your program again, you'll have forgotten how it works, and you'll thank yourself for picking variable names that make sense. However, giving a trivial identifier an overly complex name impedes overall understanding of what the program is doing almost as much as giving a non-trivial identifier an inadequate name. What? Hang on. Right, so don't be too descriptive. Good rule of thumb is to make the Good rule of thumb is to make the length of an identifier proportional to how specific and accessible the identifier is. This means an identifier that exists for only a few statements in the body of a short function can have a shorter name. An identifier that is accessible from anywhere might benefit from a longer name. An identifier that represents a non-specific number, anything the user provides, can have a shorter name. An identifier that represents a specific value, the length of an inseam in millimeters, should have a longer name. Kind of am picking up what they're saying. Like, you'd want a longer name if you want the function to be pulled from a bunch of different things so that you know you're writing like the correct thing. If it's too short, you may like have multiple things that are also short, and you know. Identifier that represents a specific value. I assume this one just has like specific information, so you should have that specific information in the identifier, is why it would be longer. What is this? Int C count. Count. Bad. What does the C before count stand for? Oh, I see. Whereas customer count is better than C count. True. Okay, I. Okay if use is trivial, bad otherwise. Index. Okay if obvious what we're indexing. Can we get some good ones in here? Total score. Okay, if there's only one thing being scored, otherwise too ambiguous. Count. Do not start names with underscore. Ooh. Why? We don't like that. That's bad. Count. Okay, if obvious what we're counting. Data. What kind of data? Time. Is this in seconds, minutes, or hours? I feel like I'm getting like grilled right now. Like I'm just like trying to, okay, but what about this though? All right. Minutes elapsed. Okay, if obvious what this is elapsed from. Okay. X1, X2. Okay, if use is trivial, but otherwise, yeah, it's similar to just like a letter I. User input 1, user input 2. Hard to differentiate between the two due to long name. Okay. Num apples. Number of apples. Good. Descriptive, yes. Monsters killed. Those are the amount of monsters killed. Descriptive. Okay. Avoid abbreviations except when they are common and unambiguous. Num, centimeters, index. I hope it's right. It's like it should be common, right? Unambiguous, index. Key insight. Code is read more often than it is written, so any time saved while writing code is time that every reader, including future you, will waste while reading it. If you're looking to write code faster, use your editor's autocomplete feature. I don't like it. I don't like autocomplete. I didn't like that I was like putting the quote, double quote down and it was putting another one. I know there's probably a setting for it, but I was trying to be like a little bit specific and then I was getting confused why the code was a little messed up, and it's because they were inserting stuff. For variable declarations, it can be useful to use a comment to describe what a variable is going to be used for, or to explain anything else that might not be obvious. For example, say we've declared a variable that is supposed to store the number of characters in a piece of text. Does the text hello world have a 10, 11, 12 characters? Depends on whether we're including white space or punctuation. Rather than naming the variable num characters including white space and punctuation, which is rather lengthy, a well-placed comment on or above the declaration line should help the user figure it out. Right, so you could have a less descriptive tag if you also explain it. Right, number of characters also, just so you know. Got it. Quiz time. Oh my gosh. Okay. Question 1. Based on how you should name a variable, indicate whether each variable name is conventional, follows best practices. Unconventional, compiler will accept, does not follow best practices, or invalid, will not compile, and why. Okay. Assume it's obvious what we're summing. Okay. The sum. Hang on. Before I look at it, I need to look at this little chart. Is sum here? I don't see sum, so I think we can use it. Yes, I think it will accept that. Am I? Conventional. We're good. We're in. Apples. Unconventional. Numbers are not allowed. Underscores are allowed, but they're saying don't do it. Unconventional. Variable names should not start with an underscore. All caps. Well, it'll accept it. Unconventional. Single word names should be in all lowercase. My variable name, it will be rejected because there's white space. Total customers, I think it will be rejected because it starts with a capital letter. Unconventional. Ooh. Variable name should start with a lowercase letter. Okay, there we know. I know, I was like, quiz time, okay. Void, hang on. Void feels like one that would maybe be here. Yep, we can't name it that because it's reserved, so it will reject it. Invalid. Void is a keyword. Keyword, that's what it is. Num fruit. Number fruit. That looks perfect. Conventional. Threesome. That would be invalid because 3 cannot. Yeah. Meters of pipe. Unconventional. Because we don't want to use underscores. Conventional. Okay. They're saying snake case. Snake case is conventional or camel case. That is snake case, and it is. If you want to do the underscores, it's good. Okay. Wow, yeah. 1.8. Let's do it. White space and basic formatting. 1.8. White space is a term that refers to characters that are used for formatting purposes. In C++, this refers primarily to spaces, tabs, and new lines. White space in C++ is generally used for 3 things: separating certain language elements, inside text, and for formatting code. Okay. Some language elements must be white space separated. The syntax of the language requires that some elements are separated by white space. This mostly occurs when 2 keywords or identifiers must be placed consecutively, so the compiler can tell them apart. For example, a variable declaration must be white space separated. Gotcha. If we typed int x without a space instead, the compiler would interpret this as an identifier and then complain that it doesn't know what identifier int x is. As another example, a function's return type and name must be white space separated. When white space is required as a separator, when white space is required as a separator, the compiler doesn't care how much white space is used as long as some exists. The following variable definitions are all valid. Right? Because it just like, it can take 10 spaces and it's just like, okay, well that's 1. I don't know why you did 10, but I'm just gonna pretend that's 1. In certain cases, new lines are used as a separator. Single line comments are terminated by a new line. As an example, doing something like this will get you in trouble. Doing a new line in the comment. This is part of the comment, and this is not part of the comment. Preprocessor directives include IOStream must be placed on separate lines. Okay. That's good to know. Quoted text takes the amount of white space literally. Inside quoted text, the amount of white space is taken literally. This hello world is different than this hello world. Because they said what they said. New lines are not allowed in quoted text. Interesting. Not allowed. Quoted text separated by nothing but white space, spaces, tabs, or new lines will be concatenated, right? Is that right? It's gonna be cut off. Cut it off. It's gonna concatenate it. Okay. Interesting. You do the new line and then the quote again. Using whitespace to format code. Whitespace is otherwise generally ignored. Alright, yeah. Whitespace is otherwise generally ignored. This means we can use whitespace whenever we like to format our code in order to make it easier to read. For example, the following is pretty hard to read. I see. So these are only the spaces that are required. That one, this new line. But everything else is smooshed. We got one here in the quote, and we're smooshed. The following is better, but still pretty dense. Okay, we've got new line after curly brackets. And then return 0. The following is even better. Oh, because of just like more spacing. Just to really like separate the paragraphs or chunks, you know? Statements may be split over multiple lines if desired. This works fine. Right. This can be useful for particularly long statements. Basic formatting. Unlike some other languages, C++ does not enforce any kind of formatting restrictions on the programmer. For this reason, we say that C++ is a whitespace independent language. Okay. This is a mixed blessing. On one hand, it's nice to have the freedom to do whatever you like. On the other hand, many different methods of formatting C++ programs have been developed throughout the years, and you'll find sometimes significant and distracting disagreement on which ones are best. Our basic rule of thumb is that the best styles are the ones that produce the most readable code and provide the most consistency. Here are our recommendations for basic formatting. It's fine to use either tabs or spaces for indentation. Most IDEs have a setting where you can convert a tab space into the appropriate number of spaces. Developers who prefer spaces tend to do so because it ensures that code is precisely aligned as intended, regardless of which editor or settings are used. That's interesting. Proponents of using tabs wonder why you wouldn't use the character designed to do the indentation for indentation. That's for sure me. Especially as you can set the width to whatever your personal preference is. There's no right answer here. Debating it is like arguing whether cake or pie is better. It ultimately comes down to personal preference. Okay, tabs is cake. People who like pie more than cake maybe do spaces. I'm just kidding. Either way, we recommend that you set your tabs to 4 spaces worth of indentation. Some IDEs default to 3 spaces of indentation, which is fine too. There are 2 conventional styles for function braces. Many developers prefer putting the open curly brace on the same line as a statement. I like same line because it tells me that like I've opened something up here. Keep reading, you know. The justification for this is that it reduces the amount of vertical white space and you aren't devoting an entire line to an opening curly brace, right? So you can fit more code on a screen. This enhances code compression and as you don't need to scroll as much to understand what the code is doing. However, in this tutorial series, we'll use the common alternative. We'll use the common alternative where the opening brace appears on its own line. Well, why? It enhances readability? I don't think so. To me, like, this enhances my readability more, having that. I need it separate for the closing so I can see that it did get closed, because that's important, but I need to know that I opened this up, you know? These feel too separate to me. I don't know. Like, one thing might not affect the other. As far as like me looking at a line of code and like getting vibes, it's so separate. I just realized I have that like that here. Is that better? Let's see. I do like that it like sections off, like it kind of makes this feel a little more of a square, but it still feels like this is like too uninvolved with all of this. And I know that it is. It's just like visually, you know? I don't know. I gotta follow the vibes. This enhances readability and is less error prone since your brace pairs should always be indented at the same level. If you get a compiler error due to a brace mismatch, it's very easy to see where. I guess that's fair. Each statement within curly braces should start one tab in from the opening brace of the function it belongs to. For example, tabbed in one tab, 4 spaces. Lines should not be too long. Typically 80 characters has been the de facto standard for the maximum length a line should be. What? Really? Okay. If a line is going to be longer, it should be split at a reasonable spot into multiple lines. This can be done by indenting each subsequent line with an extra tab, or if the lines are similar, by aligning it with the line above, which is easier to read. Okay. This is a really, 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 really long line. One extra indentation for continuation line. Okay. Text align with the previous line for continuation line. This one is short. This makes your lines easier to read on modern widescreen monitors. Also allows you to place 2 windows with similar code side by side and compare them more easily. That's true. Like, this window here, here, it goes pretty far. Let's see. Oh, okay. There's I don't know. I want to say like a quarter of the screen almost that is cut off, because almost all the text ends like here. I never see it go past here. You know, it'd be weird. Okay. Best practice. Consider keeping your lines to 80 characters or less in length. Okay. Hello. This song feels like louder for some reason. Many editors have a plugin feature or plugin extension that will show a line called a column guide at a given column at 80 characters. So you can easily see when your lines are getting too long. To see if your editor supports this, do a search on your editor's name column guide. Oh no, like the railing and everything? Or just the drawer itself? If a long line is split with an operator, what is that, extractor? Or add, I guess. Oh. I'm so sorry. That sucks. At least it's not broken. The operator should be placed at the beginning of the next line, not the end of the current line. Let's start that over. If a long line is split with an operator, the operator should be placed at the beginning of the next line, not the end of the current line. Okay, so don't have the next line start with like a number, have it start with the operator. Or don't let it start with the quote, or like have the operator first. This helps make it clear that subsequent lines are continuations of the previous lines, and allows you to align the operators on the left, which makes for easier reading. It's getting really stormy out there. Sorry. Use whitespace to make your code easier to read by aligning values or comments or adding spaces between blocks of code. Harder to read. Line up the equal signs. Harder to read. The comments, yeah. Line up all the comments. I do like that. We will follow these conventions throughout this tutorial, and they will become second nature to you. As we introduce new topics to you, we will introduce new style recommendations to go with those features. Ultimately, C++ gives you the power to choose whichever style you are most comfortable with, or think is best. However, we highly recommend you utilize the same style that we use for our examples. It has been battle tested by thousands of programmers over billions of lines of code, and is optimized for success. One exception: if you are working in someone else's code base, adopt their styles. It's better to favor consistency than your preferences. Best practice: when working in an existing project, be consistent with whatever style has already been adopted. Automatic formatting. Most modern IDEs will help you format your code as you type it in. Like when you create a function, the IDE will automatically indent the statements inside the function body. However, as you add or remove code, or change the IDE's default formatting, or paste in a block of code that's different formatting can get messed up. Fixing the formatting for part or all of a file can be a headache. Fortunately, modern IDEs typically contain an automatic formatting feature that will reformat either a selection, highlighted with your mouse, or an entire file. For Visual Studio, edit, advance, format document, edit, advance, format selection. Okay. For easier access, we recommend adding a keyboard shortcut to auto-format the active file. Okay. There are also external tools that can be used to automatically format code. Clang Format is a popular one. Best practice: using the automatic formatting feature is highly recommended to keep your code's formatting style consistent. Style guides. A style guide is a concise, opinionated document containing sometimes arbitrary programming conventions, formatting guidelines, and best practices. The goal of a style guide is to ensure that all developers on a project are programming in a consistent manner. Some commonly referenced C++ style guides include C++ Core Guidelines, maintained by Bjarne Stroustrup and Herb Sutter, Google, LLVM, GCC GNU. We generally favor the C++ Core Guidelines as they're up to date and widely applicable. Guys, 1.9, Introduction to Literals and Operators. That feels like stuff. 1.9, Introduction to Literals and Operators. Literals. Consider the following two statements. Hello world. X is 5. What are hello world and 5? They are literals. A literal, also known as a literal constant, is a fixed value that has been inserted directly into the source code. Literals and variables both have a value and a type. Okay. Unlike a variable whose value can be set and changed through initialization and assignment respectively, the value of a literal is fixed and cannot be changed. The literal 5 always has a value 5, and this is why literals are called constants. To further highlight the difference between literals and variables, let's examine this short program. Print the value of a literal. Print output 5. Right? And then X is 5. Print the value of a variable, because we can, in this one statement, we're saying output 5. Whereas this is saying X is, right now it's 5. So I'm going to say X, which right now is 5. So it's variable, not constant. On line 5, we're printing the value 5 to the console. When the compiler compiles this, it will generate code that causes character output to print the value 5. This value 5 is compiled into the executable and can be used directly. On line 7, we're creating a variable named x and initializing it with the value 5. The compiler will generate code that copies the literal value 5 into whatever memory location is given to x. On line 8, we print x. When we print x, the compiler will generate code that causes character output to print the value at the memory location of x, which has the value 5. Thus, both output statements... Hello? One moment. Do not disturb. Thus, both output statements do the same thing, print the value 5. But in the case of the literal, the value 5 could be printed directly. In the case of variable, the value 5 must be fetched from the memory the variable represents. This also explains why a literal is constant while a variable can be changed. The literal's value is placed directly in the executable, and the executable itself can't be changed after it is created. Variable's value is placed in memory, and the value of a memory can be changed while the executable is running. Oh. It kind of just hit me a little bit like speedrunners when they, with Super Mario and stuff, they'd inject memory while the game's running. It's I know that, but then reading, I know that RAM can be changed, but reading it like that, it's oh, yeah, okay, certain lines of code are just hard statements, whereas there's information that's stored in the memory and you can just change the information stored in the memory. I get it. Okay. Thus, both output statements do the same thing, print the value 5, but in the case of the literal, the value 5 can be printed directly. In the case of the variable, which we already read. This also explains why a literal is constant, why a variable can be changed. A literal's value is placed directly. We already read this. I got this. Key insight. Literals are values that are inserted directly into the source code. These values usually appear directly in the executable code, unless they are optimized out. Objects and variables represent memory, locations, and hold values. These values can be fetched on demand. Okay. We'll talk more about literals in lesson 5.2, literals. Okay. Operators. In mathematics, an operation is a process involving 0 or more input values, called operands. That produces a new value, called an output value. The specific operation to be performed is denoted by a symbol called an operator. For example, as children, we all learn that 2 plus 3 equals 5. In this case, the literals 2 and 3 are the operands, and the symbol plus is the operator. And that tells us to apply mathematical addition on the operands to produce the new value 5. Hearing the word operand, I feel like I have been thrown back genuinely to, I think, like a 5th grade class. Like I'm in like a portable, you know? I'm just like, where am I right now? Operands. Okay. In C++, operations work as you'd expect. For example, 1 plus 2. I see. We're literally saying character output 1 plus 2, so it's going to output 3. Ah, okay. In this program, the literals 1 and 2 are operands to the plus operator, which produces the output value 3. This output value is then printed to the console. In C++, the output value of an operation is often called a return value. You are likely already quite familiar with the standard arithmetic operators, from common usage in mathematics, including addition, subtraction, multiplication, and division. In C++, assignment equals is an operator as well, as are insertion, extraction, and equality. While most operators have symbols for names, While most operators have symbols for names, I see, there are also a number of operators that are keywords. New, delete, and throw. Throw it. Author's note. For reasons that will become clear when we discuss operators in more detail, the operators that are symbols, it is common to append the operator's symbol to the word operator. For example, the plus operator would be written operator plus, and the extraction operator would be written operator. What? It is common, but we're not going to, because I'm like, we haven't done this. Or maybe we did at one point. Right, operator. Feels like that'd take a long time to write that every time. For reasons that will become clear. Okay. The number of operands that operator takes as input is called the operator's arity. Some people know what this words mean. Okay, well, I'm too scared. Arity. Few people know what this word means, so don't drop it in a conversation. Expect anyone to have any idea what you're talking about. Operators in C++ come from 4 different articles. Okay. Wait, what? Operators in C++ come in 4 different arities. Oh my god. Unary. What? Unary? I say unary. Unary operators act on one operand. An example of an unary operator is the minus operator. For example, given -5, operator minus takes literal operand 5, flips its sign to produce new output value. I don't understand any of that. None of that made any sense to me. The word, why is it giving you a -5? Oh, and we're moving on. Binary operators act on 2 operands, often called left and right. As the left operand appears on the left side of the operator and the right operand appears on the right. Have a good lurk. Here's our, it's a follow emote. So I believe you should have, I'm sorry, I just love her. The lurk emote. Have a good lurk, and thank you for dropping in. It's nice to see you. Oh my gosh, one of my first followers, actually. Okay, binary operators act on 2 operands, often called left and right. As the left operand appears on the left side of the operator and the right operand appears on the right side of the operator. An example of a binary operator is the plus operator. For example, given 3 + 4, operator plus takes the left operand 3 and the right operand 4 and applies mathematical addition to produce new output value 7. The insertion and extraction operators are binary operators, taking character output or character input on the left side and the value to output or variable to input on the right side. Ternary. Ternary operators act on 3 operands. There is only one of these in C++, the conditional operator, which we'll cover later. Nullary operators act on 0 operands. There is also only one of these in C++, the throw operator, which we'll also cover later. Okay. Note that some operators have more than one meaning depending on how they're used. For example, operator minus has 2 contexts. It can be used in unary form to invert a number sign. Okay. Weird. To convert 5 to -5, or vice versa. Or it can be used in binary form to do subtraction. I think that's where I was getting confused. I was like, unary form, like like uni is one, unary. Okay. Oh my god. I got it. I was like, unary? Huh? Anyways. Chaining operators. Operators can be chained together such that the output of one operator can be used as the input for another operator. For example, given the following, 2 times 3 plus 4, the multiplication operator goes first and converts left operand 2 and right operand 3 into return value 6, which becomes the left operand for the plus operator. Next, the plus operator executes and converts left operand 6 and right operand 4 into new value 10. Okay. Multiply. Two times 3, which gives us 6, which becomes the left operator. Then it goes to the plus, adding 4, which gives us 10. Right. It's just like such a long sentence, you know, to explain it. It's like, it's good. We'll talk more about the order in which operators execute when we do a deep dive into the topic of operators. Oh my god, I thought this was operators. Oh, introduction to literals and operators. Okay. For now, it's enough to know that the arithmetic operators execute in the same order as they do in standard mathematics. Oh my god. I was about to say arithmetic. Anyways. Parentheses first, then exponents, then multiplication and division, then addition and subtraction. This ordering is sometimes abbreviated PEMDAS, or expanded to the mnemonic. Please excuse my dear Aunt Sally. She drinks a little too much. I'm sorry, just kidding. Author's note. In some countries, PEMDAS is taught as PEDMAS, BEDMAS, BODMAS, or BIDMAS instead. I did not know that. Okay.
Oh, shit. Here we go again.
Here we go again. All right. Think. All right, let's finish this out, and then I'll take a break. Got a little bit, and I love the quizzes. Oh my god, my ears itchy. Sorry. Most operators. Hang on. Return values and side effects. Whoa. Most operators in C++ just use their operands to calculate a return value. For example, -5 produces return value -5, and 2 plus 3 produces return value 5. There are a few operators that do not produce return values, such as delete and throw. We'll cover what these do later, because delete, you should be just completely removing values. Throw, I assume you're throwing a value somewhere else. So then the value will be gone because it's thrown, right? We'll cover what these do later. Some operators have additional behaviors. An operator or function that has some observable effect beyond producing a return value is said to have a side effect. For example, x equals 5 has a side effect of assigning value 5 to variable x. It's like, you should think about the consequences of assigning 5 to x, because now x is 5. Okay. That's how it's like explaining it. It feels like this, it's a side effect. It's like, okay. That's what we'll call it. The change value of x is observable by printing the value of x. Even after the operator has finished executing, character output 5 has a side effect of printing 5 to the console. We can observe the fact that 5 has been printed to the console even after character output 5 has finished executing. It's 5 and you'll like it. Nomenclature. In common language, the term side effect, that's what I was like, the term side effect is typically used to mean a secondary, often negative or unexpected result of some other thing happening, such as taking medicine, for example. Common side effect of taking oral antibiotics is diarrhea. Why do we have to say that? As such, we often think of side effects as things we want to avoid or things that are incidental to the primary goal. I do get it. There's like a side effect is just like, it's an effect that happens on the side of something that's happening, right? C++, the term side effect has a different meaning. It's an observable effect of an operator or function beyond producing a return value. Since assignment has the observable effect of changing the value of an object, this is considered a side effect. We use certain operators, the assignment operator, primarily for their side effects, rather than return value those operators produce. In such cases, the side effect is both beneficial and predictable, and it is the return value that is often incidental. Give me a second. I'm just like, huh. We use certain operators for their side effects. In such cases, the side effects beneficial and predictable. Okay. For advanced readers, it's going to be us, so we need to know what the advanced readers are knowing. For advanced readers, For the operators that we call primarily for the return values, operator plus or operator times, it is usually obvious what their return values will be. Sum or product of the operands. I forgot that, like, product is, like, when you do multiplication, the answer is product. Man, it's been a while since I've been in a math class. Let me freshen it up. For the operators, we call primarily for their side effects equals extraction. Pretty sure that's extraction. It's not always obvious what return values they produce, if any. For example, what return value would you expect x equals 5 to have? What do you mean? Both operator equal and extraction operator, when used to output values to the console, return their left operand. Oh, wait. Thus x equals 5 returns x. Character output 5 returns character output. This is done so that these operators can be chained. I'm confused what I'm reading. Oh, because we're reading the advanced readers. I'm like, what are we saying? Hang on. I'll get this though. X equals 5 returns x. Character output returns character output. For example, x equals y equals 5 evaluates as x equals y equals 5. Oh. First, y assigns 5. First, y equals 5 assigns 5 to y. This operation then returns y, which can then be assigned to x. Character output hello world evaluates as character output hello world. This first prints hello to the console. This operation returns character output, which can then be used to print world to the console. What? Okay. Talk more about the order in which operators evaluate in lesson 6.1. Operator precedence and associativity. Whew, quiz time. Yeah, I definitely need a break. Number 1. Question 1. For each of the following, indicate what output they produce. This is going to be hard. Okay. Because I was not getting it. But this is for advanced. I shouldn't understand that, you know? But I do, but I don't, you know? Okay. What is this going to output? Character output. I just feel like it's a trick question, but I'm like 7. Okay. This is just like math quiz, pop quiz time. 2. Okay. Extra credit. Oh, give me that extra credit. Give me a second. Oh, it's okay. We're doing it right now. This would be... Sorry. I'm literally just like, 14? Multiplication goes before addition, so 3 times 4 goes first, producing the result 12. 2 plus 12 is 14, okay. Extra credit, let's do this. Int x 2. Output 2 equals 5. Give me a moment. What? Just like, what a... I guess it's not equals, it's like 2 is 5, right? Like, what, like... Because what was... It was like double equals was like is equal. Equality. Oh, equality means that they are like... If we're doing like lesser or greater, they're equals. Assignment. Okay. Okay. Wait. Feel like this is wrong, but I feel that it will output 5 because here we're saying x is 2, but then here we're saying now x is 5. Am I wrong? Like we've replaced it. Maybe that's wrong. 5. X equals 5. Assigns the value 5 to x. Then returns x. The value of x is now... Where's this 2? Then printed the console. This was not explained well, but I got there. That's so weird. Hang on. X equals 5. Oh wait, I'm wrong. It will output x equals 5. No wait, 5 is the answer, right? Yeah. Oh, I did get it right. I did say 5. I'm just confused. Okay, I think it is what I just said. X equals 5, that statement assigns 5 to x, and then also returns what x is. The value of x, now 5, is then printed to the console. Okay, so yeah, I was correct. The 2 got overwritten by this statement. Okay. We got the extra credit. Okay. 110, Introduction to Expressions. We're going to BRB because I need to stretch. I need to walk around. I think we're doing well. I feel good. We're doing it. I'll be back. Bye. back, I have goldfish crisps. I needed a little bit of Sanakin. Let's get into expressions. I'm sorry, the crunching's a lot. I understand this is like a reading stream, so I'll try not to do it too much. But also this is my stream, so I'm gonna eat. It's pretty crunchy, huh? I'm seeing it like pick up in the mic like strong. Gotta think of some soft foods for streaming. All right. Put it right here so you all can hear right what I'm going for when. I'm just hoping this mic is making it more pleasant at the very least. And we have water. I can hydrate now. Okay. Expressions. Consider the following series of statements, each of which defines a variable and initializes it. Five is a function that returns the value 5. Integer 5 returns 5. Integer main, initialize variable with a literal value of 2, with computed value of 5, computed value of 10, variable value of 5. Where was that at? B was... Oh, I see, because B is defined here. 2 plus 5, 2 plus 3 was B, was a computed 5. Initialize variable E with a function return value of 5. Return 0. Note that the initializers above make use of a variety of different entities: literals, variables, operators, and function calls. Somehow, C++ is converting all of these different things into a single value that can then be used as the initial value for the variable. What do all of these initializers have in common? They make use of an expression. In general programming, an expression is a non-empty sequence of literals, variables, operators, and function calls that calculate a value. The process of executing an expression is called evaluation, and the resulting value produced is called the result of the expression, also sometimes called the return value. For advanced readers, in C++, the result of an expression is one of the following: a value, most commonly, an object or a function. We discuss expressions that return objects in lesson 12.2. Value categories: L values and R values. Nothing. These are a result of non-value returning function calls that are called only for their side effects. 2.3 void functions, non-value returning functions. Oh my gosh. Void functions were the throw and delete. For now, to keep things simple, we'll assume expressions are evaluated to produce values. I have to assess what I just read, kind of. The result, so like the side effect of an expression. It's so loud. I'm like, please. I don't like that I swallow and it picks up, like, it scares me. When an expression is evaluated, each of the terms inside the expression are evaluated. When an expression is evaluated, each of the terms inside of the expression are evaluated until a single value remains. Here are some of the examples of different kinds of expressions, with comments indicating how they evaluate. Two. Two is a literal that evaluates to value 2. Hello world is a literal that evaluates to text hello world. X. X is a variable that evaluates to the value held by variable X. 2 plus 5, operator plus, uses operands 2 and 3 to evaluate the value of 5. 5 evaluates to the return value of function 5. This one is getting me. What? Evaluates to the return value of function 5. Whatever 5 has already been indicated as, right? Sure. As you can see, literals evaluate their own values. Variables evaluate to the value of the variable. Operators, such as operator plus, use their operands to evaluate to some other value. We haven't covered function calls yet, but in the context of an expression, function calls evaluate to whatever value the function returns. What? Here, I'll do this. I think it's time. The beast is awoken. Ma'am. Would you like a one? Come in. Come in. Oh, you baby. You good girl. Come on in. You good girl. Her face. You want it? You want it? Oh. I was hoping she'd give her paw or something, but she's just giving me lovey eyes. Sit. 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 That's not sit though. That was what I was looking for first time. Sit. Hey, sit. So I'll sit up to sit down again. Wait, sit. Placement. That was a good one. Oh my gosh. Alright. Too much sodium. We're done. She's like, what do you mean? Oh, it just bounced off of her. I was trying to toss it into her mouth, like, cool. Alright, May. Sit. You want it? Oh. What was that? Roll over. She doesn't know roll over. Play dead. What is this? Sit. Hey, sit. I don't know. Did you suss out the one that I threw on you? Sit. That's a good sit. That was like a look at that sit. What is this? You give me a paw? Give me a paw? She doesn't really know paw too well. Paw? She's over it. I'm over it. We're over it. I'm just kidding. Last one for a good job. You don't have to do anything for it. Did you drop it? No, you got it. Alright. Give me a moment. Like, I feel like I can't focus because there's something like lurking. Just kidding. Okay. Reset. For advanced readers, expressions involving operators with side effects are a little more tricky. X equals 5. X equals 5 has a side effect of assigning 5 to X. Evaluates to X. X equals 2 plus 3 has a side effect of assigning 5 to value X. Evaluates to X. Has a side effect of printing value of X to console. Evaluates to character output. Okay. I'm not starting to struggle with this chapter. I'm like, expressions. Wherever a single value is expected in C++, you can use a value-producing expression instead. An expression will be evaluated to produce a single value. Expressions do not end in a semicolon and cannot be compiled by themselves. For example, if you were trying to try compiling the expression x equals 5, your compiler would complain, probably about missing a semicolon. Rather, expressions are always evaluated as part of statements. For example, take this statement. 2 plus 5 is an expression that has no semicolon. The semicolon is at the end of the statement containing the expression. So there's no semicolon here after the 3, it's after curly brace. If you were to break this statement down into its syntax, it would look like this. Type identifier expression. This is nice. This is the type, is an int. The identifier is X. 2 plus 3 is the expression. That's beautiful. That's great for my brain. I need more of this. Type could be any valid type. We choose int. Identify. Oh my god, I've been saying integer. Anyways. Identifier. Hang on. I'm confused. No, okay, no. Int is integer, right? That's the type. I'm not wrong. Am I wrong? I'm wrong. Am I? This one got a little, like, funkier. She's still looking. I have my hand in the bag, so she's like... the identifier, see, like the lowercase i's, I think went through me. The identifier could be any valid name. We chose X. Expression could be any valid expression. We chose 2 plus 3, which uses 2 literals and an operator. Expression statements. Certain expressions, such as x equals 5, are used primarily for their side effects. In this case, to assign the value 5 to the variable x rather than the value they produce. Cover side effects in lesson 1.9, Introduction to Literals and Operators. However, we mentioned that expressions cannot be executed by themselves. They must exist as part of a statement. Fortunately, it's trivial to convert any expression into an equivalent statement. An expression statement is a statement that consists of an expression followed by a semicolon. When the expression statement is executed, the expression will be evaluated. Thus, we can take any expression, such as x equals 5, and turn it into an expression statement that will compile. When an expression is used in an expression statement, any result generated by the expression is discarded because it is not used. For example, when the expression x equals 5 evaluates, the return value of operator equals is discarded. And that's fine, because we just wanted to assign 5 to x anyways. I have to read all that in my head real quick, because I was for sure doing the just reading and not absorbing it. I'm gonna munch. Pardon my chewing. I understand now. Expression statement. An expression usually goes in parentheses of a statement, but an expression statement is like its own thing as long as it has the semicolon, right? Like, I feel that, like, I don't know. I'm like, is return 0 here like one of those, you know? Like, is 0 here the expression? I don't know. Okay. Useless expression statements. We can also make expression statements that compile but have no effect. For example, the expression statement 2 times 3 is an expression statement whose expression evaluates to the result value of 6, which is then discarded. Okay. While syntactically valid, such expression statements are useless. Some compilers, such as GCC and Clang, will produce warnings if they can detect that an expression statement is useless. Well, call my code useless. I assume it's like we get the value of 6, but then like what do we do with that? Like there's no point in, it's not assigned to a variable, like it's not outputted, right? Is that what they're saying? Sub-expressions, full expressions, and compound expressions. We occasionally need to talk about specific kinds of expressions. For this purpose, we will define some related terms. Consider the following expressions. 2. 2 is a literal that evaluates to value 2. 2 plus 3 uses operator plus to evaluate the value 5. X equals 4 plus 5. 4 plus 5 evaluates to value 9, which is then assigned to variable X, Simplifying a bit, a sub-expression is an expression used as an operand. For example, the sub-expression, I understand. So like the full equation or whatever is the expression, but like the parts of it are the sub-expressions, right? Sub-expressions of X equals 4 plus 5 are X and the 4 plus 5. The sub-expressions of 4 plus 5 are 4 and 5. Okay. A full expression is an expression that's not sub-expression. All three expressions above, 2, 2 plus 3, and X equals 4 plus 5 are full expressions. It was written by Alex. Don't know who Alex is. In casual language, a compound expression is an expression that contains 2 or more uses of operators. Okay. Compound expression because it contains 2 uses of operators. Makes sense. 2 and 2 plus 3 are not compound expressions. Consider the following. What is the difference between a statement and an expression? A statement has a semicolon at the end, stating something. Expression is usually part of that statement, but there's also expression statements. An expression is like the defining characteristics of like how the statement is expressing itself, you know? Is it goth? Like, you know? That was a little lengthy, but statements are used when we want the program to perform an action, state stuff. Expressions are used when we want the program to calculate a value. That helps me a lot. How does it express itself? Calculate a value. That's important. Question 2. Indicate whether each of the following lines are statements that do not contain expressions, statements that contain expressions, or are expression statements. Int X. I'll come back to this one. This one is a statement that contains an expression. Statement contains an expression. This one I feel that Is X on its own an expression? I don't think it is. Unless it's pulling it, but I'm like, just on its own, int X. I'm gonna say doesn't contain an expression. Yes. This is a variable definition statement. X is not an expression in this context because it is being defined, not evaluated. We did it. C. X equals 5, semicolon. That, good sir, is an expression statement. Expression statement, X equals 5, is a call to operate equals with two operands, X and 5. Semicolon makes an expression statement. Extra credit. Foo. Foo is a function. Does not contain. Oh shit. I did feel like functions did. We did cover that, and I was like, what are we talking about? Function calls are part of an expression. So this is an expression statement. Shit. Operator is a binary operator. Character output X. So this is an expression, not an expression statement. It contains, is a variable. Wait, what am I saying? Huh? A statement that contains an expression, right? Since that's the entire statement, this must be an expression statement. I thought maybe, but I didn't know. Oh, I guess that's the int. But no, because that feels weird. Hang on. Operator is a binary operator. So character output must be the left-hand operand, which that's what I saw it as. And X must be the right-hand operand. Since that's the entire statement, this must be expression statement. Oh. I guess that's rough. Determine what values the following program outputs. Do not compile this program, just work through it line by line in your head. Okay. Don't tell me what to do. No, just kidding. Excuse me. Include IOStream. We are asking the IOStream to give us its library. Int main, the main body, right? Character output. 2 plus 3, 5. So we've got 5 showing in the console already. Just from the get-go, let's do that. And then, wait, what am I supposed to say though? Like, just determine what values the following program outputs. So we have a 5 outputted. X is 6. Y is X minus 2. So 4. 6 and 4. Character output Y. So we have 4. 5 and 4. Z is empty, but Z equals X. So Z is 6. And so character output, 6 times 6, 36. Return 0. We're done with the program. So we have 5, 4, 36. And we have new lines, so, right? Yes. We did it. We did it. Developing your first program. 1.11. Oh my god. Oh my god, yeah. I'm so excited, but I need chippy break. Give me a second. She gave up. She's turned away. Oh. Are you sleepy, girl? Okay. The preceding lessons have introduced a lot of terminology and concepts that we'll use in just about every program we create. In this lesson, we'll walk through the process of integrating this knowledge into our first simple program. Multiply by 2. First, let's create a program that asks the user to enter an integer, waits for them to input an integer, then tells them what 2 times. We're probably gonna have to do a BRB once they ask us to write this, but I have to wash my hands if I'm gonna use the keyboard. I was like, I'm reading so I can have these cheesy chips. Okay. Enter an integer, waits for them to input it, tells them what 2 times that number is. The program should produce the following output. Assume I entered 4 as input. Enter an integer 4. Double that number is 8. How do we tackle this in steps? Best practice, new programmers often try to write an entire program all at once, then get overwhelmed when it produces a lot of errors. Better strategy is to add one piece at a time, make sure it compiles, and test it. Then, when you're sure it's working, move on to the next piece. Just looking at this feels scary, but I think I want to go wash my hands. Before we even continue, I want to just try to write this, see what we can do from what they taught, and then see what this lesson has to teach us from what we have known, you know? I will BRB. BRB. I'm back. Let's just get into it. I think leave the return. Let's just remove this. Right? We got a fresh little file here. Enter an integer. Okay. We want to initialize the variable before we ask the user for it. Pretty sure. So we'll do int. Hello, where am I? Int. X. Semicolon. And then we're gonna std. Is that wrong? That feels wrong. If I do character output, it'll help me find it, right? We're already stuck. No, I'm just kidding. I see it so much. Part of this that I struggle with is just remembering syntax. Like, how exactly does it want it spelled, actually? We want the... Hang on. Alright, I just need to look through. We're gonna Google. Beep. Okay. Still feels wrong though. You did write it like that, but then was it happy with that character output? Do we need to do that new line? It's not for right now. We'll test this and stuff before we check what the answer is. It's not mad at us yet, right? Enter an integer. And then we'll do, we do want new line, right? New line. And then sin. Input is going to be X. Ew, that looks weird. It's upset. It's upset at me. Why are you mad? Identifier is undefined. Oh, whoops. Another guy. We needed another guy. She's happy again. Get over there. Okay. Character input is going to be X. And then and then we wanted to another character output. Oh, hang on. No, why are you upset? Alright, never mind. We'll just not do the new line there, right? We'll leave it. It was happy before. What I'm trying to figure out is this 8. Do I want to set it as like variable Y? Or like identifier Y? Or do we just do the expression statement? Like X times 2. That's the expression statement. I think we need to do that. Do I need a space? X times 2. I don't think there is a space. There shouldn't be. I don't like that. Yeah. Right? XXXX. Is it going to output that? We should not do, because we needed to say double that number is. So we shouldn't just do an expression statement. Hang on. Okay. Double that number is no, we don't want new line yet. Hang on. Is and then this will be an expression. I don't know if it needs to be in parentheses, but X times 2. She good? Okay. Yeah, I'm like, is this right? Okay, let's find out. Okay. Succeeded. Okay, we don't need that. Oh, it's the other one. Hang on. Just weep whoop. Kill me. I'm just kidding. We need the new line to flush here, right? Is that important? Sounded important. Flush away. F7. 5. Enter an integer. See, maybe we don't need new line there because it wants it like next to it. Yeah, let's get rid of it actually. Okay. We're gonna get this perfect. Enter an integer. 4. Double that number is 8. We did it. I think honestly that's it, right? We even flushed it. How do we tackle this in steps? Now what I would have done is maybe we could like set it up when we're doing like bigger projects and stuff. I did kind of just try to work this through off the top of my head because it's small and simple. But I did we're chickening. I did want to kind of write down like what of these I think would be needed and in what order before I started inputting all of the information of like enter integer and like write it down on scratch paper. It feels like there's something about it being tactile that I feel like I'd work it out easier, but this was so simple that we could just logic our way through it. Let's see how close this is to theirs. I don't know. I feel that actually this would look nicer, but I don't know. It did feel like it was getting a little long there, you know? So like, yeah, maybe it should go over here. Best practice. New programmers often try to write an entire program all at once, like we just did. And then get overwhelmed when it produces a lot of errors, which we did not do. A better strategy is to add one piece at a time and make sure it compiles and test it. Then when you're sure it's working, move on to the next piece. All right, we'll leverage that strategy here. As we go through each step, type, don't copy and paste, each program into your code editor. I typed it all, right? I'm pretty sure because I wanted to copy this character output one again, and I was like, nope, I'm gonna type it. Get overwhelmed. Oh, sorry, wrong part. We'll leverage that strategy here. As we go through each step, type, don't copy and paste, each program into your code editor, compile, and run it. First, create a new console project. Now, let's start with some basic scaffolding, but that is what we started with, our scaffolding. We had the include. Okay, I felt like that was the scaffolding. We've been using it so much. We know we're going to need main function, since all C++ programs must have one. So if your IDE didn't create a blank one when you created a new project, let's create one. Main, turn 0. We know we're going to need to output text to the console and get text from the user keyboard, so we need to include IOStream for access to character output and character input. Now let's tell the user that we need them to enter an integer. Is that what we did? Yes. It throws me off because the colors are different, but it's whatever. Okay. See, I initialized the X first. Okay, I guess we've asked first. Enter an integer. At this point, your program should produce this result, enter an integer, and then terminate. Next, we're going to get the user input. We'll use character input and the insertion operator to get the user's input. But we also need to define a variable to store the input for later use. Okay. Huh. What's happening? Hang on. I'm confused why the output... Like these feel wrong. Am I wrong? Okay, it's upset. I was like, why? We ran into a compile error. I was like, why is he, what? Sorry, I'm just reading it because I'm like shocked. I was like, why are we doing this? Uh-oh, here's what the author got on Visual Studio 2017. We ran into a compile error. First, since the program compiled before we made this latest update and doesn't compile now, the error must be in the code we just added. Lines 7 and 8. That significantly reduces the amount of code we have to scan to find the error. Line 7 is pretty straightforward, just a variable definition, so the error probably isn't there. That leaves line 8 as the likely culprit. Second, this error message isn't very easy to read, but let's pick apart some key elements. The compiler is telling us it ran into the error on line 8. That means the actual error is probably on line 8, or possibly preceding the line, which reinforces our previous state assessment. Next, the compiler is telling you that it couldn't find an extraction operator that has a left-hand operand of type stdi stream, which is the type of character input. Put another way, operator exertion doesn't know what to do with character input, so the error must be with our use of character input or our use of the extraction operator. See the error now? If you don't, take a moment and see if you can find it. Here's the program that contains the corrected code. Okay. I was like, what's happening? Like, what? Why would he do that? Okay. Now the program will compile and we can test it. The program will wait for you to enter a number, so let's enter 4. The output should look like this. Enter an integer. Almost there. Last step is to double the number. Once we finish this last step, our program will compile and run successfully, producing the desired output. I think I went a little try hard there with like initializing the X first. Like, I guess I didn't need to. There are at least 3 ways we can go about this. Let's go from worst to best. Or is it like not good that I initialized it? Like, I don't know. I felt that it was saying like it's important to do that and like specify. I don't know. Let's go from worst to best. The not good solution. Worst version. Number. Okay. So we went with just X is num. Ew, num equals num times 2. Double num's value, then assign. It like replaces what num is. I don't like that. In this solution, we use an expression to multiply num by 2, then assign that value back to num from that point forward. Num will contain our double number. I don't like that. Yeah. Why this is a bad solution. Before the assignment statement, num contains the user's input. After the assignment, it contains a different value. That's confusing. We overwrote the user's input by assigning a new value to the input variable. What did I do? Okay, yeah, I was just like, just output the equation. before the assignment statement, it's confusing. We overwrote the user's input by assigning a new value to the input variable. So if we wanted to extend our program to do something else with that input value later, like triple the user's input, it's already been lost. Yeah, it's been replaced. The mostly good solution. Less bad version. Num. It's initialized x. Character input num. Double num. I didn't do that. Double that number is double num. This solution is pretty straightforward to read and understand and resolves both the problems encountered in the worst solution. Primary downside here is that we're defining a new variable, which adds complexity, double num, to like double kill, double num. To store a value we only use once. Yeah, we're defining a new variable, which, because I almost was like, should we do a y? And I was like, nah, let's just output what the equation is. To store a value we only use once. We can do better. Oh my god. It wasn't as clean as, well, yeah, wait, yes. That is, if I put this back how I had it. I thought I'd, oh, hello, I'm clicking in OBS. I'm tired. This is how I had it. And it's the same. Okay, well, I initialized it before asking, but I guess I didn't have to. But we did that. X. Double that number is x times 2. And we even did the new line. We flushed it. Use an expression to multiply number times 2 at the point where we are going to print it. I think literally besides putting the initialized x at the start, we wrote it exactly how the preferred solution, all without reading the lesson. This was like it wasn't a pop quiz, it was like a test, you know? It's like we did our chapter 1 test. That's crazy. This is the preferred solution of the bunch. When character output executes, the expression number times 2 will get evaluated, and the result will be double num's value. That value will get printed. The value in num itself will not be altered, so we can use it again later if we wish. This version is our reference solution. I am so proud of us. Author's note. The first and primary goal of programming is to make your program work. That was what I was like, let's get it to get that output and then let's see how it's different. And I love when it's exactly the same. It's so great. Oh my God. It's so fun. Is to make your program work. A program that doesn't work isn't useful regardless of how well it's written. However, there's a saying I'm fond of. If you have to write a program once to know how you should have written it, you have to write a program once to know how you should have written it the first time. I like that. That actually is really good. This speaks to the fact that the best solution often isn't obvious, and that our first solutions to problems usually aren't not as good as they could be. Not us. Not here. No, I'm just kidding. When we're focused on figuring out how to make our programs work, it doesn't make a lot of sense to invest a lot of time into code we don't even know if we'll keep. So we take shortcuts. We skip things like error handling and comments. Ooh, yeah. We sprinkled debugging code throughout our solution to help us diagnose issues and find errors. We learn as we go. Things we thought might work don't work after all, and we have to backtrack and try another approach. The end result is that our initial solutions often aren't well structured, robust, error-proof, readable, or concise. So once your program is working, your job really isn't done, unless the program is a one-off throwaway. The next step is to clean up your code. This involves things like removing or commenting out, temporarily debugging code, adding comments, handling errors, formatting your code, and ensuring best practices are followed. And even then, your program may not be as simple as it could be. Perhaps there is a redundant logic that could be consolidated, or multiple statements that can be combined, or variables that aren't needed, or 1,000 other little things that could be simplified. Too often, new programmers focus on optimizing for performance when they should be optimizing for maintainability. Very few of the solutions presented in these tutorials came out great the first time. Rather, they're the result of continual refinement until nothing else could be found to improve. And in many cases, readers still find plenty of other things to suggest as improvements. All of this is really to say, don't be frustrated if and when your solutions don't come out wonderfully optimized right out of your brain. Except it does. No, just kidding. That's normal. Perfection in programming is an iterative process, one requiring repeated passes. We're gonna get it. Author's note. One more thing. You may be thinking, C++ has so many rules and concepts. How do I remember all this stuff? Short answer is you don't. C++ is one part using what you know and two parts looking up how to do the rest. I knew I wanted to do the character output. I didn't know how to write it. I looked it up. That's exactly it. That's like IT. It's like I know how to get to this window, but then I don't know what to look for. What exactly is the registry I'm looking, Just look it up. Everything. Looking up how to do the rest. As you read through this site for the first time, focus less on memorizing specifics and more on understanding what's possible. Then, when you need to implement something in a program you're writing, you can come back here or to reference a site and refresh yourself on how to do so. Quiz time. Whew. Oh my gosh. Okay. Modify the solution to the best solution program. What? Oh, okay. Modify it to the best solution. I don't need to modify it. It's already there. So that it outputs like this, assuming user input 4. So we just need to add. Please. Please. Okay, yeah, I do want the new line. I know, I'm stunned. I really do want to keep doing this like twice a week. We'll do Tuesdays, our usual, but probably Saturdays. Saturdays are for me, and this is what I really want to be putting my energy into right now. Oh, I'm seeing this as different. Double 4 is, so I need to say, instead of that number. Hang on. Don't do that to me. Double is, double 4 is 8. And then we're gonna do triple. Four is x times 3. And then new line statement. There we go. You know what? Let's go ahead and let's move this. Why not? Have it be perfect. Perfect. Succeeded. Enter an integer. 4. Double 4 is 8. Triple 4 is 12. We did it. Is this? Oh, let me close this. Is this perfect? Oh, except we're doing X still instead of num, but whatever. Yeah. Oh, I was wondering, like, where should I have my, like, separations? So, like, here. And there. Okay, because the character input, and then this is the output. And then we do want return on its own. Input, output. I kind of feel like I want them. That feels better to me, somehow. Like, this is the input, this is the output. Don't listen to me, though. I only code perfectly. No, just kidding. Oh my goodness. Next lesson, chapter 1 summary and quiz. I think we need to finish this one and then we're good. Like, let me, hang on. I just want to see the, is it just 1.x? Yes. Oh my God, we're going to finish chapter 1. And then we'll start up chapter 2 Tuesday. Tuesday. I'm scared. Okay. Oh, phone is just like sitting open. Can I show off my phone again? I'm sorry. Just, I love it. And she's so pretty. Okay. Chapter review. A statement is a type of instruction that causes the program to perform some action. Right? A statement telling the program to perform some kind of action. Statements are often terminated by a semicolon. Once the semicolon's there, that's the statement's done. On to the next statement. A function is a collection of statements that execute sequentially. They're in the curly brackets. Collection of statements that execute sequentially. Every C++ program must include a special function named main. When you run your program, execution starts at the top of the main function. Go from top to bottom, sequentially. In programming, the name of a function, or object, type, template, etc., is called its identifier. The rules that govern how elements of the C++ language are constructed is called syntax. A syntax error occurs when you violate the grammatical rules of the language. Comments allow the programmer to leave notes in the code. C++ supports 2 types of comments. Line comments with a / right? And then, yes. And run to the end of the line. Block comments start with a / and go to the paired * symbol. Don't nest block comments. Like, you can't have the block comment and then do another block comment within a block comment. You're gonna make a mess. Don't make a mess. Don't do it. You can use comments to temporarily disable lines or sections of code. This is called commenting out your code. Data is any information that can be moved, processed, or stored by a computer. A single piece of data is called a value. Common examples of values include letters, A, numbers, 5, and text, hello. A variable is a named piece of memory. Okay. A variable is a named piece of memory that we can use to store values. In order to create a variable, we use a statement called a definition statement. When the program is run, each defined variable is instantiated, which means I said initialize. I instantiated that variable. Sorry. Which means it is assigned a memory address. We instantiated X before asking for X. We assigned a memory address, and then we said, user, put your stuff in that memory address that we just instantiated. A data type tells the compiler how to interpret a piece of data into a meaningful value. An integer is a number that can be written without a fractional component, such as 4, 27, 0, -2, or -12. Not 0.3. Okay? Copy assignment via operator equals. The equals is the assignment operator. I remember that. It's not equals, it's assignment. Operator assignment can be used to assign an already created variable a value. Copy assignment can be used to assign an already created variable a value. Okay, that sounded weird when I said it. The process of specifying an initial value for an object is called initialization. The syntax used to initialize an object is called an initializer. Simplified, C++ supports 6 basic types of initialization. Default initialization, where you're just saying X, this integer is X. Most cases leaves variable with indeterminate value. Usually performs 0 initialization. I was just like, this is what we do, so what's 0 initialization? Performs 0 initialization, I think means either no initialization happens or it's applying 0 to that value, right? Because it's better to have 0 as a value than to have something not there when it gets initialized. Like this would be like in X, and then it's like, but where's X? Whereas this, if it's on its own, would just assume it's 0. I think I'm wrong. It also is saying that C++ does not default initialize to 0. I don't know. We'll find out. Okay. We have copy initialization. X. What's the word? What did we just said? Assignment. X assignment 5. Direct initialization. That's with the parentheses. We're saying like X is this. Direct list initialization. That's interesting. Copy list initialization. Narrowing conversions disallowed. I don't know what any of that is meaning. We'll figure it out. We'll learn. Direct initialization is sometimes called parenthesis initialization. And list initialization, including value initialization, is sometimes called uniform initialization or brace initialization. You should prefer brace initialization over the other initialization forms and prefer initialization over assignment. Yes, that is what we did, I'm pretty sure. Include list initialization, including value initialization, is uniform. Brace initialization. Prefer brace initialization. Okay. Although you can define multiple variables in a single statement, it's better to define and initialize each variable on its own line in a separate statement. Character output and extraction operator allows us to output the result of an expression to the code. Endline produces a new line character, forcing the console cursor to move to the next line, flushes any pending output to the console. The new line character also outputs a new line character, but it lets the system decide when to flush the output. Be careful not to use / new line. Crap. I did do that. Character input and insertion operator allow us to get a value from the keyboard. A variable that has not been given a value is called an uninitialized variable. Trying to get a value of an uninitialized variable will result in undefined behavior, which can manifest in a number of ways. C++ reserves a set of names called keywords. These have special meaning within the language and may not be used as variable names. A literal constant is a fixed value inserted directly into the source code. Examples are 5 and hello world. An operation is a process involving 0 or more input values called operands. The specific operation to be performed is denoted by the provided operator. The result of an operation produces an output value. Unary operators take one operand. Binary operators do take 2 operands, often called left and right. Ternary operators take 3 operands. Nullary operators take 0 operands. An expression is a sequence of literals, variables, operators, and functions. Hang on. An expression is a sequence of literals, variables, operators, and function calls that are evaluated to produce a single output value. I understand now, because a whole function on like another file could do a whole ass giant calculation, and you could just be like, give me the answer for that function that it got. So that's why it can be that's why a function can be an operand. Okay, sorry. Function calls that are evaluated to produce a single output value. The calculation of this output value is called evaluation. The value produced is the result of the expression. An expression statement is an expression that has been turned into a statement by placing a semicolon at the end of that expression. When writing programs, add a few lines or a function, compile, resolve any errors, and make sure it works. Don't wait till you've written your entire program before compiling it for the first time. Focus on getting your code working. Once you're sure you're going to keep some bit of code, then you can spend time removing or commenting out temporary debugging code, adding comments, handling error cases, formatting your code, ensuring best practices are followed, removing redundant logic, etc. First draft programs are often messy and imperfect. Most code requires cleanup and refinement to get to great. Quiz time! Let's do this. What is the difference between initialization and assignment? How many times can a variable be initialized or assigned a value? How many times? What? Okay. Initialization is like reserving a spot in the memory, whereas assignment is assigning what the value is being put into the memory. How many times can a variable be initialized or assign a value? Like, my answer is like once. Like, you can initialize it once, and then if you initialize it again, it's that one time. You can do it, I assume, over and over. Right? But it's like you can't initialize something twice, like in a row. You know what I mean? I get that. Okay. Initialization provides a variable with an initial value at the point of creation. Oh. Assignment gives a variable a new value after the variable has already been defined. So I think it does, that curly brace does give it a 0. It gives it a 0 so that the program isn't going to be scared if there's nothing there, because there is a 0. And then it gets replaced. Okay. Since a variable is only created once, it can only be initialized once. A variable can be assigned a value as many times as desired. Okay, I was confused by the question. How many times can a variable be initialized or assigned a value? It sounds like they're both like together, but it's like, it's two separate questions. How many times can a variable be initialized? How many times can we assign a value? Right. And I was like, we can only create the variable once, but also we can replace it as many times. Like, I was like, it's both. Like, huh? When does undefined behavior occur? What are the consequences of undefined behavior? Undefined behavior occurs when, well, it can occur when like syntax is wrong. It can also occur if values are not initialized, or variables are not initialized. Results are like code you don't, or like output you don't want, or the code crashing, or like inconsistent results. Undefined behavior occurs when the programmer does something that is ill-specified by the C++ language. Consequences could be almost anything, from crashing to producing the wrong answer to working correctly anyway. Okay, question 3. Here we go. We're gonna finish this up. Write a program that asks the user to enter a number and then enter a second number. The program should tell the user what the result of adding and subtracting the two numbers is. I like that. The output of the program should match the following, assuming inputs of 6 and 4. Hint, to print a period and use a new line. I know that. I know. Okay. So we need to ask for two numbers. We need to ask for a number and then ask for another number. We're not asking for two numbers. Ask for a number, ask for another number. And then we'll just output what those are added and subtracted from each other. Yeah, we can do this. All right. We're just going to use this that we have here, clearly. Enter an integer, x. We've initialized x. Enter it. So that's going to be the 6th one. And then we're going to do character output, extraction, enter another integer, and then we want y. Hello. Character input y. And then we're going to output that we're going to say x plus, oh my gosh, plus, it's frustrating, 6 plus y is x And then this is going to be actually x plus y. And then new line. We do want the period there. We're gonna get this. We're gonna get this. Let me just refresh real quick. Enter an integer. 6. Enter another integer. It's gonna be 4. 6 plus. Oh, this isn't. No. These damn quotes. You're gonna get me. X plus y is. I'm sorry, is x plus y. Okay, that looks correct to me. So I am going to, I'm going to copy this. Just please, it's exactly the same except for 2 symbols. There we go. I was like, wait, hello. Plus, minus. I think we've got it. Let's find out. So excited. Okay. Enter an integer. 6. Enter another integer. 4. Oh, we want some more spaces. I see that. But still, that's it. So let's just add a couple spaces here. Sorry, I'm gotta be the perfectionist like that, I guess. This is kind of how I was in my Java class, where I was like, you're showing me how the output needs to look, I'm gonna do it exactly. 6 plus 4 is 10. 6 minus 4 is 2. Okay, let's do it again, but this is just like literally a calculator. We literally just made a little calculator. So like, let's do like cute numbers. It's literally a calculator. And then if we do like, I was wondering if we did like a negative numbers, and then like -3. Look at it go. -7 plus -3 is -10, and -7 minus -3 is -4. Oh my goodness, we're mathing, we're programming, we're coding. Let's see. Let's show solution, because I think we got it. Wow-wee. Hang on. Enter an integer. I'm looking back and forth like it's literally, sorry. I think it's spot on. Hell yeah. All right. Our little calculator. That's literally me right now. Literally. Wow. That's chapter 1. That was a Saturday. That was worth it. Goodness gracious. I'm so happy. Let's find out who to raid out to. I'm so glad we did bonus stream. Oh, I know who to raid out to. Psh, easy. Hang on. All right, we did it. We did it. We are going to read out to Hammy, Airhammer, Animal Crossing. I was literally like, I need to drop in for more streams, so we're going to do it right now. I will probably be back tomorrow. I say probably, but it's like, I'm pretty sure I'm going to be back tomorrow. We're going to be doing some Ensign Michael commissions. We're going to be working on some stuff. Let's do it. We're going. And thank you all for being here. Thank you for anyone who's like watching through these lessons. We did chapter 1. We did it. We got through it, and I feel like I've already learned so much. I feel like I'm back in it. I feel like a programmer again. We're gonna know what we're doing soon. Okay. All right, everyone have a good weekend. See you tomorrow, and